Hi, Steve Smith.
And this is Julie Lerman.
In this module of Domain-Driven Design Fundamentals, you will learn about domain events and anti-corruption layers, two patterns for decoupling how the domain model communicates internally and with other systems.
We'll start with domain events, which can be used to separate concerns, allowing different areas of the application to evolve independently, and sometimes helping with scalability as well. You'll learn how to identify domain events in your system and how to design domain event classes. Then we'll show you domain events being used in a simple application so you can get a feel for the structure and the workflow.
Then you'll get to see the domain events we built in our sample application, which are a bit more realistic. After this, we'll turn our attention to another important element of domain modeling, anti-corruption layers, which can be used as translators between bounded contexts and legacy APIs.
Domain events are a critical part of a bounded context. They provide a way to describe important activities or state changes that occur in the system. Then other parts of the domain can respond to these events in a loosely coupled manner.
In this way, the objects that are raising the events don't need to worry about the behavior that needs to occur when the event happens. And likewise, the event handling objects don't need to know where the event came from. This is similar to how repositories allow us to encapsulate all of our data access codes so the rest of the domain doesn't need to know about it.
We can also use events to communicate outside of our domain, which we'll look at in just a moment.
Another thing that's worth remembering is that domain events are encapsulated as objects. This may be different from how you're used to coding events. It certainly was different for me when I first started learning about them. For example, in a user interface, events are more commonly written as some form of a delegate in another class. But here, they're first-class members of the domain model.
Right. Although you can implement domain events using techniques like the event keyword in C#, the domain events themselves should be full-fledged classes. In fact, all of these parts of domain-driven design are defined as objects in our domain model.
Von Vernon describes domain events simply, saying we should use a domain event to capture an occurrence of something that happened in the domain. The domain events should be part of our ubiquitous language. The customer or domain expert should understand what you're talking about when you say, when an appointment is confirmed, an appointment confirmed event is raised.
You may already be familiar with the idea of events from working with user interfaces.
Many user interface clients like .NET Windows Forms, Electron, or web pages like the one shown here make heavy use of events and event handlers. In this example, there's a single page with a single button, and in the markup you can see there's an onClick attribute in the button that leads to a little JavaScript method defining what the app should do in response to a user clicking the button.
Events are helpful because they let us avoid a lot of conditional logic. Instead, we can write code that signals a certain thing has happened, and we can have other code in our system listen for these signals and take action accordingly.
So in this kind of code, you don't have a separate class for an onClick event. And it may take some getting used to that now in our model, we're going to create a whole class to represent an event. Domain events offer the same advantages to our model as the events in the user interface. Rather than having to include all of the behavior that might need to occur whenever the state of one of our objects changes, instead, we can raise an event. Then we can write separate code to deal with the event, keeping the design of our model simple and helping to ensure that each of our classes has only one responsibility. Essentially, a domain event is a message, a record about something that occurred in the past, which may be of interest to other parts of our application or even other applications entirely.
Be especially attentive to these kinds of phrases when discussing the application with your domain experts. When this happens, then something else should happen. If that happens, notify the user when, or inform the user if. These types of phrases frequently refer to situations that are important to the domain expert, the system, or the user. It might therefore be worth modeling these types of things as domain events. You may also discover behavior in the application that will benefit from being treated as domain events that maybe the domain expert isn't initially aware of.
Remember that domain events represent something that happened. Since we can't generally alter history, this means they should be immutable. It's a good idea to name the event using terms from the bounded context ubiquitous language, describing clearly what occurred. If they're fired as part of a command on a domain object, be sure to use the command name. Here's some examples.
Depending on the application, it might be important to have events to represent when a user has authenticated, when an appointment has been confirmed, or when a payment has been received.
Be sure to only create events as you need them in your model. You should follow the Yagni principle. That's you ain't gonna need it. In other words, don't create domain events unless you have some behavior that needs to occur when the event takes place and you want to decouple the behavior from its trigger. You really only need to do this when the behavior doesn't belong in the class that's triggering it. Here are some more things to keep in mind when you're creating domain events. We've already mentioned that domain events are objects, but to be more specific, each domain event should be its own class. It's also usually a good idea to note when the event took place, since frequently the code that's handling the event might run some time after the event occurred. It can be helpful to create an interface or a base class that defines the common requirements of your domain events. For example, capturing the date and time the event occurred.
Also, when you're designing your event, you need to think about the event-specific details you want to capture. If it's related to an entity, you might want to include the current state of the entity in the event's definition. Think about what information you would need to trigger the event again. This can provide you with the set of information that is important to this event. Similarly, you may need to know the identities of any aggregates involved in the event, even if you don't include the entire aggregate itself. This will allow event handlers to pull the information back from the system that they might require when they're handling the event. Ideally, domain event objects should be lightweight, so you want to be sure you capture sufficient information to handle the event, but not so much that the event object itself becomes bloated. Since domain events are immutable, they're typically fully instantiated via their constructors, and since they're simply noting that something has happened in the system, they don't usually have any behavior or side effects of their own.
We've put together a simple console application that we're going to use to demonstrate the value that domain events can have in your application. The idea behind this is to strip things down to as small a level as possible. Then, we'll also show how domain events are playing a real role in a more real-world way when we get to our veterinary scheduling application. This is a .NET console application with dependency injection. The main program just loads the needed services and runs the app. The app has a simple run method which goes through the following steps. We can step through it with the debugger so you can see the output in real time. The app loads services and starts running. It shows what happens when an appointment is created using a service. The service calls a factory method that creates the appointment. After instantiating the appointment, the factory method sends an email, which you can imagine includes code like what is in the comments here. Then it similarly sends a notification to the user interface, again with code like what's in the comments, before finally returning to the service. The service then saves the new appointment in the database. Then, the app creates a different appointment and saves it directly using a repository instead of a service. And once more, the notifications and the save occur in the same order. Finally, the appointment is confirmed, which triggers some UI notification, and then that change too is saved. The main thing to take away from this example so far is that the appointment class has a lot of concerns. The act of creating an appointment, especially, involves a lot of code that could fail. It's also worth noting that notifications and emails are going out before the state of the entity is saved. So if something goes wrong, users will have been told the operation was successful, and people may have been notified via email, when in fact the update itself might never go through.
The reason we're showing the behavior both from a service and with the appointment directly is because our domain should be designed to work either way. Earlier in this course, when you learned about domain services, we explained that forcing all operations on your domain to go through a set of services tends to lead to an anemic domain. Ideally, your aggregates and entities should behave correctly whether they're being used directly or through a set of services. One way we can improve this design would be to move the responsibilities of actually sending emails or updating the UI to helper methods or other services. Then we could call them from appointment.create instead of having all the code in here. This would make for less code inside of appointment.
That would definitely be better, but it would still mean that appointment would need to be updated every time a new requirement came along. There's a principle we can use to avoid that, though, called the Hollywood principle.
I love the name of this principle. Its name comes from an old saying from Hollywood agents: don't call us, we'll call you.
Exactly. Applied to software, the principle is closely related to dependency inversion from Solid. Instead of forcing appointment.create to have to know about and call every possible thing that might be involved in the appointment creation workflow, instead, it can just let the app know something happened, and let the app respond by calling handlers.
Instead of putting all the logic into this method, potentially making it huge and complicated and really hard to read, we move that logic into handlers, and the app calls the handlers. We don't call the handlers, the app calls us. And beyond just reducing the amount of code and responsibility inside appointment, this approach also lets us make sure that notifications to the user don't occur until persistence is successful. And it still keeps the model's behavior consistent without requiring a service to perform any of the work. Let's see how it works.
Domain events is a pretty simple pattern, but you do need to have some plumbing code to support it. You also need to think about whether you want your events to fire before or after persistence. In many cases, what you really want is post-persistence events, for the reasons we mentioned above. You want to make sure your persistence succeeds before you send any notifications outside of your app. Also, although occasionally I've used them for validation in the past, ideally, your domain events and handlers should never fail. That is, don't build your behavior around exceptions that might be thrown from event handlers. Use a different pattern if you need that type of behavior.
In this simple demo, which mirrors how our sample app works, we just need a collection of events on each entity. We're creating simplistic types to represent domain events and their respective handlers. You can implement the logic to find and call handlers whenever an event is dispatched in a number of ways. For this sample, we're using the Mediator NuGet package created by Jimmy Bogard. Steve mentioned that you'll need some plumbing to start, and that plumbing is the interfaces, or base classes if you prefer, for handler and domain event classes. In our example, we're using interfaces. Here's the iDomain event interface and the iHandle interface.
Once you've set up your event and handler interfaces or base types, it's time to create some events and their associated handlers.
For this scenario, there are two things happening. An appointment is scheduled or created, and an appointment is confirmed. An event is something that already happened, so we name our events in the past tense, and we have appointment created and appointment confirmed. The event classes are pretty simple and just include the instance that triggered them, so handlers have access to any properties they might need from it. Once the events have been defined, you just take each individual responsibility out of the original method and create a separate handler for it. It's fine to have multiple handlers for the same event. Ideally, your design shouldn't depend on the order in which the handlers execute, but if it does, you could think about adding a sequence to your handler interface and ensuring they're called in sequence order.
The last thing you need to do is register or record the events on the entity. In this sample, that just means adding them to the list of events that are on that entity. The actual implementation for dispatching the events is done in the repository after the save is successful, and in our veterinary sample, this work is done in the dbcontext savechanges method.
Let's step through the code again now that it's using domain events.
The app starts up as before. We enter the appointment.create method.
And look how much smaller that method is now.
Definitely. It's way easier to see what's going on here. Now the domain event is added to the collection, but notice that when we step over this, nothing actually happens yet.
Right, it's just holding it until after the entity is persisted.
Which is now. Notice that we're in the repository save method, and for every event that we have stored on this entity, we're using Mediator to publish it at this point in time.
This is still in process on the same thread. There's no out-of-process queue or anything involved here.
Right, there's nothing to install using this pattern except for Mediator, and that just runs in memory. And of course, you could wire this up with your own code that simply loops over your set of events and then dispatches out to your handlers. There's nothing that says you have to use Mediator. Notice in the output that the database save occurred and then the UI and email notifications.
As expected, we only triggered side effects outside our domain after persisting. Now let's see the version that uses the repository directly and doesn't bother going through the service.
We basically see the same behavior: database save, UI, email.
All that's left now is the confirm and save, which should look similar. Entity saved, and then the UI is updated.
That's basically it. I created a small GitHub repo, which has just this sample in it. It's at github.com/ardalis/domain events console. There's a branch there showing how things work without events. Of course, you can also download it from the course details.
If you want to start your solution with all of this plumbing already in place, you can use Steve's Clean Architecture Solution template, which is also on GitHub. He is one productive guy. Everything shown here is already in place in the template, which is designed for you to use as a starting point for your app. Now let's look at how we're leveraging domain events in the veterinary front desk scheduling app that we've been working with. Again, we'll start by showing you the code, and then we'll debug through it so you can see it in action.
In our appointment class, we're going to record a domain event when certain changes are made to the appointment. So, if we scroll down and take a look at the update room method, you'll see that it creates and saves an appointment updated event. The same is true for the other update methods, like update doctor, update start time, etc. They each will create an appointment updated event and pass it the current instance of the appointment. And then this is saved into the entity's events collection.
In the case of the confirm method, it's similar, but it creates a different event, an appointment confirmed event. Essentially, the appointment entity can trigger two kinds of events directly, changed and confirmed. And you'll notice it only does so if an actual change takes place. Calling an update that doesn't change the current value will not trigger a new event.
Let's take a look at the appointment updated event, and this is similar to the one we saw in the simpler console app in the previous demo. It inherits from base domain event, which is defined in our shared kernel, and it adds a UTC timestamp property called date occurred that is set when the event is created. This can be useful for debugging purposes. The only other property the class takes is the appointment itself. The appointment confirmed event, shown here, is similar.
Notice that these domain events are all defined in the core project with our domain model. For this sample, they're in an events folder in the root. However, in a large application with many events, it might make more sense to put them with the aggregate that they correspond to, in this case, the schedule aggregate. There's one more domain event in our sample, which is the appointment scheduled event. It's similar in structure to the others, but it's actually created elsewhere.
Once you start working in event-driven applications, it can be a bit more difficult to follow the flow of execution in the app where events are concerned. It really just takes some getting used to, and then you'll find it to be second nature. The best way to see where events are raised and where they are handled is by looking at an individual event and examining its references. Looking at appointment scheduled, you can see that it is handled in the API project and in the core project. It is only created inside of the schedule aggregate itself. Let's have a look at where that happens.
In Schedule, the Add New Appointment method creates and saves the appointment scheduled event after adding the appointment to its collection and marking whether or not it's conflicting. Once the schedule is saved, any appointments that have had domain events added to their respective collections will have them dispatched after the save to persistence is complete.
Before we step through the code, let's have a look at one of the appointment scheduled event handlers. The thing to notice is that these handlers don't get created or called anywhere in our code. That's that Hollywood agent again from the Hollywood principle saying, don't call us, we'll call you. The event dispatching logic, in this case using mediator, is what calls these handlers at runtime. But at compile time, nothing references them directly.
Now let's see the flow of domain events in our application when we change an appointment. We'll modify this appointment for my little baby, Samson, and change the appointment from a wellness exam to a diagnostic exam. But a diagnostic exam takes more time, and this will automatically change the duration of the visit, which should trigger a conflict with one of Samson's other appointments. Yes, he likes to go to the vet quite a lot.
The change initially hits the appointment update endpoint. It loads the schedule and the appropriate appointment and calls its update methods. In this case, the only one that has a change is the change to the appointment type. This in turn adds an appointment updated event. Once the change is saved, the event is dispatched. The API project also has a handler, appointment update handler, that responds to this event by sending a message to the Blazor client using a SignalR hub. This will trigger a real-time notification in the app.
What about communication between bounded context or apps using events? Applications and microservices frequently use events to communicate too, but these aren't domain events since they extend beyond a single domain. They're frequently called integration events, and they may be defined as part of your domain or in a separate project or package. For simplicity, ours are here in this integration events folder.
The front desk has just two integration events. The appointment confirm link clicked integration event is published by another app and consumed by this one. An appointment scheduled integration event is an event this app publishes and another app consumes. It's important that the structure of the published and consumed types match, which is why frequently a shared package is used to define these kinds of events.
We don't have time to dive deeply into distributed application architecture, but one thing you need to remember when designing integration events is that they typically will be enriched and denormalized when compared to a similar domain event. For instance, the appointment schedule domain event just has a reference to appointment, and that only has IDs for the client, patient, and doctor. However, the integration event includes many more details like client name and email, patient name, and doctor name.
The reason for this is to ensure that consumers of the event have enough information from the event to perform whatever actions they need to without having to immediately call back to the publishing app to ask it for more details. You can imagine that the performance of the system would suffer if every time an appointment event was published, one or possibly many apps that were consuming that event turned around and immediately had to make calls to this app's API asking for client details, patient details, and doctor details. Hence, we have a handler that is responsible for taking in a domain event and enriching it with the additional details shown here on the integration event. We'll put these integration events to use in the next module.
The last topic we want to discuss in this module is anti-corruption layers. An anti-corruption layer, as the name implies, helps to prevent corruption in your domain model.
Right, just like superheroes help to fight corruption, these layers provide a sense of security to your model when it needs to interact with other systems or bounded contexts.
Returning to our mind map, you can see that the anti-corruption layer is used to translate and insulate as part of a context map, mapping between a bounded context and foreign systems.
When your system needs to communicate with other systems, especially legacy applications that weren't written or modeled as well as your current system, you need to be careful not to let assumptions and design decisions from that system bleed into your model. For instance, if the other system's model includes a customer, even if that customer refers to the same actual business customer, it's likely that it will be modeled differently than a customer in your system. It's best to have a layer that can translate to and from other systems' models. In DDD, this is the job of an anti-corruption layer.
Right. Like we mentioned in the beginning of the course, even other bounded contexts in your own system may be different enough to merit having an anti-corruption layer in place to protect the two distinct models from one another. And of course, legacy applications frequently use very different models from newer systems. An anti-corruption layer isn't a design pattern. However, it's usually comprised of several design patterns. The job of the layer is simply to translate between the foreign systems model and your own.
In addition to translating the objects themselves, the anti-corruption layer can also clean up the way in which you must communicate with the other system. It may provide a facade to simplify the API, or an adapter to make the foreign system behave in a way that is known to your system. You can learn more about these design patterns in the Design Patterns library on Pluralsight.
We're usually most concerned with having an anti-corruption layer in place when communicating with legacy systems. Eric Evans notes why that's important.
Even when the other system is well designed, it is not based on the same model as the client. And often, the other system is not well designed.
Since this is a fundamentals course, we're not going to dig deeply into anti-corruption layers because they can be fairly complex, as well as very customized to each scenario. But here's an example structure of one, which comes from Eric Evans' book, showing how an anti-corruption layer can connect your beautiful system on the left with a not-so-beautiful system on the right.
I really like this diagram. I think Eric had some fun putting it together.
Gee, what gives you that impression, Steve?
Of course, in the middle you can see how the anti-corruption layer is using a facade and some adapters. But on the right, it's protecting us from a big, complicated interface, some messy classes, and some things we just don't even want to know about.
Right. And of course, your own system is comprised of an elegant class, a very expressive class, and of course, even more good stuff. And maybe even some stuff we should be refactoring as well.
There's no one way to create an anti-corruption layer. Whatever you need in order to insulate your system from the systems it works with is what you should put inside of this layer, which should allow you to simplify how you interact with other systems, ensure that their domain decisions do not bleed into your design, and ensure any necessary translation is done along the way. We've covered some new topics in this module, and there's a few new terms that we want to make sure we review. Domain events are a type of object that actually represents something that occurred within the domain that other parts of the system may find interesting and want to tie their behavior to. And this is a great way to keep your system decoupled and to keep your individual objects simpler because they don't have to know about all of the behavior that might occur when some event takes place.
We also referred to the Hollywood principle, which can be summed up as, don't call us, we'll call you. This principle is related to the dependency inversion principle from Solid and is frequently used to decouple systems from one another. Instead of us putting all the logic we need in our code, we architect the system so that it calls back to us at the appropriate time. And we put our code into handlers that the app calls, rather than directly coupling our model to these actions.
And finally, we looked at anti-corruption layers, which can be used to ensure that our model that we work so hard to produce doesn't become polluted by the models of other systems we work with based on objects they wanted to return to us or the type of API that they want us to code to. So we put anti-corruption layers in place to shield our model from those other systems or bounded contexts that we might work with from our bounded context.
In this module, we introduced domain events, and hopefully you have a good idea of what they are at this point.
We've talked about how you can identify opportunities to use domain events based on the kinds of requirements your customers give you, as well as when you see code in your model that's doing too much and could be more loosely coupled.
We gave you some tips for designing and naming domain events, and then we showed them in action, both in a relatively simple console app as well as in our much larger veterinary clinic sample application.
Finally, we introduced the concept of anti-corruption layers, which use a variety of design patterns to insulate our model from the design choices of other applications or bounded contexts. Here are a number of resources where you can learn more about domain events and anti-corruption layers. Some of these, including a few Pluralsight courses, we mentioned in this module, but there are others that we find to be relevant even if we didn't explicitly mention them.
Up next, we're going to wrap up this course by adding a new feature to the application. Because of our clean architecture and well-designed domain model, it's going to be pretty easy to integrate into our existing app.
I'm Steve Smith.
And I'm Julie Lerman, and thanks for watching this module of our Domain-Driven Design Fundamentals course.